Hello, folks. Welcome to a survey of the physical sciences. My name is Stan Forrester. I'm your instructor over Summer B. And let's talk a little bit about the course. Okay. Summer B means we are on an extremely abbreviated schedule. Um, the way I've got it set up right now, we're going to do one module for the first 2 weeks. Let you guys get your feet, figure out navigation, figure out registration issues, so on and so forth. At that point, at the end of module 2, week 2, we're going to have to go into double modules. Okay, so we're going to do the third week is going to be modules 3 and 4. Fourth week is going to be 5 and 6, and then so on until we're done. Um, Everything has to be in by the final day due date. This schedule is just that compressed that I have to get the grades in exactly as soon as that due date goes in. I have to enter those. Okay, so please do not fall behind. Um, you are able. I opened up everything so that you can go ahead and look at any of the materials. If you have a little bit of extra time, I'm not going to hold anybody back. Okay, like I said, if you've got a little extra time this week and you don't have time next week, get those readings done. Okay. Um, got a couple discussions in there. Please introduce yourself. Oh, yes, we have a student introduction board. Please go in there and introduce yourself so that I know that you are present and I can mark you present and you don't get dropped from the course. Okay. That was good. Okay. I talked about that, the abbreviated schedule. Module 1, we're going to talk about uh, the scientific method. Basics of the scientific method. You're going to have videos on that. You're going to have readings on it. But I like Neil deGrasse Tyson's definition. The scientific method is whatever we need to do to keep from fooling ourselves. There are things we want to believe. There are things that we want to believe. And the human mind is wonderful at telling us that, oh, yeah, that's true. It's a little bit like AI that way, okay? You know, that little confirmational bias. If you think that something is true, then you are so primed to see evidence that supports that conclusion and not see evidence that doesn't support it. What the scientific method is designed to do is to make sure that we don't ignore the evidence that says you're wrong, okay? Sometimes we use blind studies. Okay, like for instance, we'll take two sets of patients in, and we will. Um, well, this is not a physical science. Okay, physical science is the study of non-living matter and the physical universe. Okay, that's your definition of the physical sciences. But a control, an experiment with a control is something like this. You bring patients in, you give one set of placebo, you give one set the actual medicine, and you see if there's a difference. You see if there's a difference. Sometimes that difference is so very small that you have to do this study with hundreds or even thousands of patients in order to see that just like 4 or 5, that 0.0% that says that it's going to work a little bit better. Um, Hopefully your medicine will work, be a little more effective than that. But to see these very small effects, you have to do that. Sometimes, in order to keep from fooling ourselves, we have to use a double blind study. Not even the researchers administering the medicine would know whether or not the patient is getting a placebo, because just by interacting with the patient, like, oh, hey, you look so much better, we could be encouraging them to engage in something that's called the placebo effect, where if you believe you're getting better, you actually do get better a little bit, okay? And we would like our medicines to work better than the placebo. Okay, so let's talk a little bit about converting decimal to scientific notation. You have a whole module on this. Let's say we have something like, all right, so scientific notation. Scientific notation, it has two parts. It has a power of 10 that follows everything, and before it has a number that's between, it's greater than 0 but less than 10. Greater than 0 but less than 10. Okay, if you'll just work it out for yourself, you'll see why. If it's going to be 10 times 10 to the 10th, you just write 10 times 10 to the 11th, 1 times 10 to the 11th. Okay, so it'd be probably a decimal like 3.14, and then we would multiply it by a power of 10. 3.14 times 10 to the 10th. Okay, well, let's do something a little better. Okay, 3.14 times 10 to the third. Okay, so that's 3.14, a multiplication symbol, 10, and an exponent with number raised up, raised to the third power, and that means a 1 followed by 3 zeros. That 3 means there's going to be 3 zeros. So 3.14 times 1,000, or 3,140. Okay, and then you'll learn to convert back and forth between them. We do that because sometimes in physics we work with very, very large numbers, and carrying around all those zeros um, can get a little confusing. And so it just basically keeps us from making mistakes. Okay, it's easier to drop a decimal place than it is to change a 3 to a 4 or something like that. All right, we know how to add and subtract, okay? The human beings are pretty good at that. But copying numbers over and over, not so good. Okay, metric prefixes. Okay, we're going to be using the system international units. It's French word. Okay, basically you know it as the metric system. It's not, once you get down to the nitty gritty, it's technically not the same as the metric system. Um, the System International was adopted a little bit later and is derived from the metric system. Okay, and it uses many of the same prefixes. Okay, we use meters for length, seconds for time, kilograms for mass. What's the other one? Current would be in amps, and temperature is in Kelvin. Or Celsius. But in physics, if we're going to do physics, we're probably going to work with Kelvin instead. The only difference between Celsius and Kelvin is where we put the zero mark. For Celsius, 0 degrees Celsius is the freezing point of water. 0 Kelvin is absolute zero, where all molecular motion stops. And by the way, it's not something we can actually reach. Okay, so it's more of a theoretical point than anything else. Um, all of the rest of the units are, there's a great deal of effort being put into defining all the rest of these units in terms of physical constants, so that you don't have to go into a vault someplace and figure out what the difference is, what the distance is between two scratches on an iridium bar. That used to be the meter. Okay, now it's defined in terms of the certain number of wavelengths of a particular photon emitted by a particular decay, and well, that particular distance. And then the second, of course, is how long it takes to traverse that same distance. Okay, our first physical science is going to be physics, sometimes called the mother of all sciences. Um, and you're going to study Newton's three laws. Okay, Okay, let's talk a little bit about difference between a law and a theory. Okay, so quantum theory, quantum electrodynamics, probably one of the most um, precise theories that we've ever come up with in human history. Okay, it's accurate down to 10 to the minus 40. You make measurements that are down to 10 to the minus 40 seconds, and so on and so forth. Okay, that's an unprecedented level of precision. Okay, general theory of relativity. Okay, it predicts the large scale motions of the universe, gravitation, time contraction, all sorts of things that we can see and measure, and it's still a theory. Why? Theories can be disproven. Okay, all scientific knowledge is provisional. Is provisional. Okay, we could sort of like I don't know, if you went to church, they gave you um, divinely revealed knowledge that is considered perfect. Da, 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 da. Okay, and if we didn't understand it, that was our problem. Okay, scientific knowledge is a human edifice, something built by humans for humans. Okay. And as such, when it doesn't meet our needs, we change it. We figure out why it was wrong, and then we change it. Okay. And we could have a whole discussion on why certain sciences get uh, emphasized at certain points in history. Like, for instance, why did the expansion of navigation suddenly get people really interested in astronomy um, and the development of celestial navigation? Okay, why did that very same problem get us interested in very precise timekeeping? Okay, um, Newton's laws. Newton's laws of motion, however, are not a theory. They are a definition. Newton's laws of motion cannot be proven wrong. Okay. For instance, the first law of motion, that an object in motion will remain in motion unless acted upon by an external force. Basically, that defines an external force. Newton's first law is a definition. It tells you what the definition of a net external force is. If there's any change in the velocity, you have a non-zero net external force. That's the definition. If you don't see it, there is no net external force. Okay. It's a definition. The second one, force equals mass times acceleration, um, or the net force is equals to the mass times acceleration. One certainly hopes that a particular mass has just one motion, one acceleration, one velocity. Otherwise, it's no longer a single object. Okay, and that's a definition too. It defines mass and it defines force. You can't really define force without defining mass. You can measure acceleration. You can invent clocks to get the time that it takes to go from here, point A to point B. You can get measuring sticks to measure force and mass. You can't define one without the other. No, I was thinking of possible thing. Okay, the last one is forces come in pairs. They're equal in magnitude, opposite in direction, and that is simply an observation that turns into a definition. Okay, and well, maybe that one is not a definition, but I'll have to think on that one for a little bit. But the first two definitely are. In any case, go to your student introduction, introduce yourself, start in on your study materials, and please try to have that done before Sunday evening at midnight. Okay? It's good to meet you. By the way, check in. I absolutely need to have you check in so that I can uh, do the attendance verification. Okay? Have a great week.